channel. This video is about consistency of a solution of linear equation. A system of linear equations is said to be consistent if it has at least one solution. Otherwise, the system is considered inconsistent. Here, the consistency of a solution of linear equation depends on if the system of equation, that is system of linear equation, has at least one solution or not. If it has at least one solution, you can consider the given system of linear equation is consistent. Otherwise, we consider the system of linear equation as inconsistent. We have a note on consistency of a linear solution. The system of equation, that is system of equation, is written as Ax is equal to b. Here a and b are coefficients of a matrix. X is a number of unknowns. Here the system of equation Ax is equal to b may or may not possesses a solution. If the system possesses a solution, it may or may not be the only solution. Here the system of equation is given by Ax is equal to b. It may contains a solution or may not contains a solution. If the system possesses a solution, in that also we have a condition, it may or may not be the only solution for a given system of linear equation. The system of equation is represented by a matrix equation Ax is equal to b is consistent if row of A is equal to row of A is to b. Here row of A is nothing but a rank of a matrix A and row of A is to b. Here A is to b represents the augmented matrix. I will show by solving the problems. Here the system of equation represented by matrix equation Ax is equal to b is consistent if it is system of a linear equation Ax is equal to b is said to be consistent, means condition is row of A must be equal to row of A is to b. Here row of A is nothing but rank of a matrix A and row of A is to b is a rank for an augmented matrix A is to b. Suppose row of A is equal to row of A is to b, which is equal to R. Then the condition for two types of solution are as follows. First condition is unique solution. Here row of A is equal to row of A is to b. Here row of A is some value and row of A is to be some value that is equal to R. That means row of A is same as that of row of A is to b. In that condition, two type of solution holds. First is unique solution. Unique solution means row of A is equal to row of A is to b, which is equal to R, which is equal to n. N is nothing but number of unknown solutions. That's about unique solution. Another one is infinite solution. That means row of A is equal to row of A is to b, which is equal to R, that R is less than n. N is nothing but number of unknowns. Here R is nothing but row of A is equal to row of b, that is rank for a augmented matrix A is to b. If this rank for an augmented matrix is less than that of number of unknowns present in a given problem, that means we can conclude that the given system of linear equation has infinite solution. Third note is, if row of A is not equal to row of A is to b, then we can conclude that solution is inconsistent. Here we have to show the system of linear equation Ax is equal to b is consistent, means this property must be hold, that is row of A must be equal to row of A is to b, that is equal to some R. If it has consistent, it has two conditions, that is unique solution, it is infinite solution. Unique solution means this R must be equal to number of unknowns. Infinite solution means if R is less than number of unknowns, you can conclude that the system of linear equation has infinite solution. In the similar way, if row of A is not equal to row of A is to b, here rank of a matrix A is not equal to rank of augmented matrix A is to b, then we can conclude that the solution is inconsistent. Next we shall see what are all the working procedure to find the consistency of a solution of linear equation. First step, consider augmented matrix A is to b and reduce to echelon form by elementary row operations. Here they will give one system of linear equation. From that we have to consider augmented matrix as A is to b. Here A is nothing but a coefficient in the left side of an equation and b is nothing but a right side value of an equation. I will show in a problem. We have to reduce this augmented matrix to echelon form by elementary row operation. In previous videos we discussed how to reduce values into an echelon form by elementary row operations. That's the first step. Second step is write down row of A and row of A is to b to decide the consistency of system of equation. Here consistency of system of linear equation depends on row of A and row of A is to b. So that next step is we have to find out row of A and row of A is to B to decide the consistency of system of equations. Next point, the echelon form of A is to B is converted back to system of equations to obtain the solution. Here we obtain echelon form of A is to B value here. With the help of echelon form of A is to B, we have to find the equation. With the help of equation, we have to solve the values or solution for a given system of linear equation. That is how to solve the problems of consistency of solution of linear equation. Here is a first problem. Test for consistency and solve x plus y plus z is equal to 6, x minus y plus 2z is equal to 5, 3x plus y plus z is equal to 8. Here they have given a linear equations, that is 3 linear equations. For this we have to find the consistency of a solution of linear equation. First step, we have to consider an augmented matrix for this linear equation. Here augmented matrix is nothing but A is to B. Here matrix A is to B is nothing but an augmented matrix. Here A is nothing but coefficients of x, y, z in these 3 linear equations. B is nothing but this right side value of the given linear equation. Here A is here in the first linear equation, that is x plus y plus z is equal to 6. First row is 1, 1, 1 is to 6. That is our A is to B for the first row, that is for the first linear equation. Similar way A is to B for the second linear equation is 1 minus 1, 2 is to 5. In the similar way for the third row A is to B is 3, 1, 1 is to 8. So this is our augmented matrix, that is A is to B. A is nothing but coefficient for x, y, z in left hand side. Similarly, B is nothing but the values in the right hand side. That is our augmented matrix for a given linear equation. Once you obtain the augmented matrix, our aim is to find row of A and row of A is to B. That means rank for a matrix. We have to find the rank for a matrix is nothing but we have to reduce this to an echelon form of a matrix, and we have to find the number of non-zero rows in an echelon form of a matrix is nothing but a rank. We already discussed in a previous videos. For that, we have to take some of the elementary row operations to reduce this to an echelon form of a matrix. That is, first step is here we have to reduce this to an echelon form of a matrix. Means first condition is the leading entry in each row must be 1. Below this leading entry all the values must be 0. Here in the first row they already given the leading entry is 1. Our aim is to reduce this, that is below this leading entry we have to obtain this value as 0. Here we have to reduce this second row as 0 and this value is also 0. For that, elementary row operation is R2 implies R2 minus R1. Here we have 1. 1 minus 1 we get a value as 0. In the similar way, R3 implies R3 minus 3 R1. Here we have R3 as 3. 3 minus 3 into R1, that is 3 into 1 is 3. 3 minus 3 we get a value as 0. So we obtain a new matrix as here first row is same, that is 1, 1, 1 is to 6 is same. Second row changes to here 1 minus 1 is 0, minus 1 is minus 2, 2 minus 1 is 1 is to 5 minus 6 is minus 1. In the similar way, R3 implies R3 minus 3 R1, that is 3 minus 3 into 1 is 0, that is 3 minus 3 is 0, that is 1 minus 3 into 1 is 3, 1 minus 3 is minus 2, here also 1 minus 3 is minus 2 is to 8 minus 3 into 6, here 3 into 6 is 18, 8 minus 18 we get a value as minus 10. So this is our new matrix obtained if we apply an elementary row operation as R2 implies R2 minus R1, R3 implies R3 minus 3 R1. So below this leading entry all the values are 0. Next condition, here for the second row we can obtain this value as 1 easily. Next condition is this value also we have to obtain value as 0. That is below this leading entry all the values must be 0. For that, next condition is we have to change this elementary row operation as R3 implies R3 minus R2. So we obtain a matrix as A is to B is first row is same, second row is same, third row changes to 0, 0, minus 3 is to minus 9 because R3 is changes to R3 minus R2. So we obtain an echelon form of a matrix like this. Call this as equation number 1. To obtain a rank of a matrix means we have to reduce this to an 1. Here also we have to reduce this to an 1. For that we can divide this equation by minus 2. Here we can divide this row by minus 3. We obtain a rank of a matrix. Once we reduce this to an echelon form of a matrix, next step we have to find row of A is to B and row of A. Here Row of A is nothing but rank for this matrix is, here number of non-zero rows are 3 because here no 0 row present, therefore row of A is 3 here. In the similar way, for the rank of a matrix for this whole augmented matrix, we obtain as here row of A is to B is also 3. Here for the row of A is to B means you have to consider whole matrix. Here the number of non-zero row is, here this also non-zero row, this also non-zero row, this also non-zero row. So we can conclude that row of A is to B is 3 here. Here row of A means you have to consider this matrix. Here also there are 3 non-zero rows. Therefore we can conclude that row of A is equal to row of A is to B. Since row of A is equal to row of A is to B, the system of equation is consistent. Here the system of linear equation is said to be consistent means row of A must be equal to row of A is to B. Next you have to find it as unique solution or infinite solution. That's the next step. Here row of A is to B is 3, row of A is 3. We can take this as our R. This 3 value is R. Here rank is nothing but the R. Number of unknowns, that is n, is equal to 3. Here we have to find the values of x, y, z. So we have 3 unknowns in a given matrix. So number of unknown n is 3 and R, that is rank for a given augmented matrix, is also 3. So once you obtain R and n, since R is equal to n is equal to 3, here number of unknown is also 3 and rank value is also 3. Therefore the system of equation will have unique solution. We already discussed in a note. If R is equal to n satisfies, the system of equation will have unique solution. If R is less than n, we can conclude that the system of equation has infinite solution. Since the system of equation has unique solution, from the equation 1, we have to consider an equation as, here from 1, here this is a equation 1, that is echelon form of an augmented matrix. In that, for the first row, we can conclude an equation as x plus y plus z is equal to 6. You have to observe carefully. With the help of augmented matrix, that is echelon form of an augmented matrix, we obtain a new linear equation as, for this first row we can conclude that this here coefficient of x is 1, coefficient of y is also 1, coefficient of z is also 1, which is equal to 6. We can write this as x plus y plus z is equal to 6. For the second row, here the coefficient of x is 0. 0 into x is 0 itself. So no need to write x value, plus into minus, the coefficient of y is minus 2 plus coefficient of z is 1, which is equal to minus 1. That's our next linear equation, that is minus 2y plus z is equal to minus 1. In the similar way, for the third row, here x coefficient is 0, y coefficient is 0, z coefficient is minus 3, which is equal to minus 9. We can write the linear equation as minus 3z is equal to minus 9. So with the help of these 3 values, we have to find the value of x, y, z. That's the procedure. Here the last value is here minus 3z is equal to minus 9, which implies solving this equation we get a z value as 3. Here minus 3z is equal to minus 9, here minus minus gets cancelled, z is equal to, if 3 goes to the right hand side, that becomes 9 by 3, 3 ones are 3 threes are, hence we obtain a z value as 3. Once you obtain z value as 3, substitute this z value as 3 in this equation, we get a value of y. With the help of y and z, we have to substitute in this value, we obtain a value of x. So consider this second linear equation, that is minus 2y plus z value is 3, which is equal to minus 1. So we get here minus 2y, we take this value to the right hand side, that becomes minus 2y is equal to minus 1 minus 3 is minus 4, hence we get y value as 2. So we obtained y as 2, z as 3. So substitute in this value. Here x plus 2 plus 3 is equal to 6. Here 2 plus 3 is 5. If we take to the right hand side, that is 6 minus 5, which is equal to 1. Therefore x value is equal to 1. Therefore we obtain a unique solution for a given system of linear equation as x is equal to 1, y is equal to 2 and z is equal to 3. So this is how to test the consistency for a given system of linear equations. We shall solve some more problems so that you can understand in a better way. Test for consistency and solve. X minus 2y plus 3z is equal to 2. 3x minus y plus 4z is equal to 4. 2x plus y minus 2z is equal to 5. Here they have given system of linear equation. We have to test for the consistency. First step, we have to consider an augmented matrix as A is to B. Here A is nothing but a coefficient in the left hand side of a system of linear equation and B is our right side of a system of linear equation. Here A is 1, minus 2, 3. Here coefficient of x is 1, coefficient of y is minus 2, coefficient of z is 3. That's the first row. Second row is coefficient of x is 3, coefficient of y is minus 1, coefficient of z is 4. Third row is coefficient of x is 2, coefficient of y is 1, coefficient of z is minus 2. Is 2. First row is 2, second row is 4 and third row is 5. So this is an augmented matrix. Next we have to reduce this augmented matrix to an echelon form to obtain rank for a matrix A and rank for a matrix A is to B. For that we have to obtain an echelon form means first step means the leading entry in each row must be unity. Here in the first row the leading entry is 1 obviously. So next condition is below this leading entry we have to find all these values as 0. So to obtain the value as 0 means we are using an echelon form, that is elementary row operation as R2 implies R2 minus 3R1, R3 implies R3 minus 2R1 because here we have 3 minus 3 into 1 is 3, 3 minus 3 is 0, here 2 minus 2 into 1 is 0. So we obtain a new matrix as first row is same, that is 1 minus 2, 3 is to 2. Second row is here R2 is 3, here 3 minus 3 into 1 is 0. Here R2 is minus 1 minus 3 into minus 2, that is plus 3 into 2 is 6. Minus 1 plus 6 is plus 5. Here R2 is 4 minus 3 into 3 is 9. 4 minus 9 is minus 5 is to 4 minus 3 into 2 is 6. 4 minus 6 is minus 2. Similarly, R3 is 2 here. 2 minus 2 into 1 is 2. 2 minus 2 is 0. Here R2 is 1. 1 minus 2 into minus 2. It is minus 2 minus plus 2 into 2 is 4. That is 1 plus 4 is 5. Similarly, here R3 is minus 2 minus 3 into 2 is 6. Minus 2 minus 6 is minus 8 is to 5 minus 2 into 2 is 4. 5 minus 4 is 1. So, next step here in the second row the leading entry is 5. So, to obtain it as unity, if we divide this by 5, we obtain as 1. So, next below this leading entry all the values must be 0. Here we have 5. For that, the elementary row operation reduced to, here we have to change R3 as R3 minus R2. Not R1, but to change by R3 by R3 minus R2 because here also 5, here also 5. 5 minus 5 we get a value 0. So we get A is to B as first row is same, second row is also same, third row changes to here 0 minus 0 is 0, here 5 minus 5 is 0 and minus 8 minus of minus 5, that is minus 2 minus plus 5. Minus 8 plus 5 is minus 3 is 2. Here we have 1. 1 minus of minus 2 is plus 2, that is 1 plus 2 is 3. This is our reduced echelon form matrix. So call this as equation number 1. Here this 3 matrix, here these 3 rows are A is to this, here whole matrix is our A is to B. So observing the matrix A, here we have 3 non-zero rows. So we can conclude that row of A is 3 and also observing whole matrix, that is row of A is to B. Here this matrix is A is to B. So here also 3 non-zero rows. Therefore we can take it as row of A is to B is 3, row of A is 3 because 3 non-zero rows. Since row of A is equal to row of A is to B, we can conclude that the given system of equation is consistent. Next step, we have to find whether the consistent, that is system of equation is consistent, has unique solution or infinite solution. Here row of A is to B is 3, here row of A is 3. Therefore, we can take this value as R, that is R is nothing but rank. Here this 3 is our R. Similarly, number of unknowns in a given system of linear equation is 3. Here they have given 3 values, that is x, y, z. So n value is 3. Here R value is 3, n value is 3. Since R is equal to n is equal to 3, the system of equation will have unique solution. We already discussed in a note. Here if R value and n value are same, the system of equation has unique solution. If R is less than n, the system of equation has infinite solution. So from equation 1, we obtain 3 linear equation as here From equation 1, we obtain an value as, that is x minus 2y plus 3z is equal to 2. This is from first row. Similarly, from second row, we obtain as 5y minus 5z is equal to minus 2. And from third row, we obtain minus 3z is equal to 3. So these three are obtained from equation 1, that is echelon form. We reduced echelon form matrix A is to B. With the help of that, we obtain these three equations. So solving this minus 3z is equal to 3, we obtain z value as minus 1. If this goes to the denominator, that is 3 divided by minus 3 is 3 ones are, that is minus 1. That is our z value. Next step, substituting this z value in second equation, we obtain y value. That is, consider 5y minus 5z is equal to minus 2. Substitute z as minus 1. We get 5y minus 5 into minus 1, which is equal to minus 2. Here minus into minus plus, 5 into 1 is 5. This goes to the right hand side. We get minus 2 minus 5, that is our minus 7. So we get to 5y is minus 7. So we get y as minus 7 by 5. This 5 goes to the denominator. We get a y value as minus 7 by 5. Next, substituting, that is, consider this value and substitute y value as minus 7 by 5 and z value is minus 1. You obtain x value. So x minus 2 into y is minus 7 by 5 plus 3 into z is minus 1, which is equal to 2. Here this is 3 into minus 1 is minus 3. It goes to the right hand side. And this is minus to minus plus. 2 into 7 is 14. 14 by 5 goes to the right hand side. That also becomes minus. Here we have, this is minus 3. It goes to the right hand side, means 2 plus 3 is 5. 5 minus 14 by 5. That is our x. Here you have minus to minus plus. Goes to the right hand side, becomes minus 14 by 5. Here it is 2. Minus 3 goes to the right hand side. That becomes plus 3. 2 plus 3 is 5. That is x is equal to 5 minus 14 by 5. Here take LCM as 5. We get 5 into 5 is 25. 25 minus 14 by 5 is 11 by 5. That is our x value. Therefore, we can conclude that the unique solution is x is equal to 11 by 5, y is minus 7 by 5 and z is minus 1. This is the unique solution for a given system of linear equation. This completes the problem. We shall move on to another problem. Test for consistency and solve 5x plus 3y plus 7z is equal to 4, 3x plus 26y plus 2z is equal to 9, 7x plus 2y plus 10z is equal to 5. Here first step we have to consider an augmented matrix, that is A is to B. Here A is nothing but coefficient in the left hand side of this system of linear equation and B is 4, 9 and 5. So first row is coefficient of x is 5, coefficient of y is 3, coefficient of z is 7. In the second row the coefficient of x is 3, coefficient of y is 26 and coefficient of z is 2. Third row is coefficient of x is 7, coefficient of y is 2 and coefficient of z is 10. B is 4, 9 and 5. So we have to reduce this to an echelon form matrix to obtain a rank. Here no need to find the first condition of echelon form matrix, that is the leading entry in each row must be 1. Here the leading entry is 5. So if we divide this throughout by 5, we get a leading entry as 1. So no need to take that condition. Second condition is below this leading entry all the entries must be 0. So to obtain that, elementary row operation is, here R2 implies R2, that is 5R2 minus 3R1. Here we have 3, here we have 5. So multiply this by 5 and this by 3, we get the R2 as 5R2 minus 3R1. Similarly R3 is, here we have 7, here we have 5. So multiply this by 5, here multiply this 5 by 7. So R3 is 5R3 minus 7R1. So we obtain a new matrix as, here first row is same, second row is, here 5 into 3 is 15, 15 minus 5 into 3 is 15, 15 minus 15 is 0. Here 5 into 26 minus 3 into 3, that is 9. 5 into 26 minus 9 is 121. Here 5 into 2 is 10, 10 minus 7 into 3 is 21. So we get a value as minus 11. In the similar way, here we have 5 into 9 minus 3 into 4, we get a value as 33. In the similar way, R3, that is 7 is our R3, that is 5 into R3 is 35, minus 5 into R3 is 35 minus 35, we get a value as 0. R3 is 2, so 5 into 2 is 10, 10 minus 7 into 3 is 21, we get a value as minus 11. Here R3 is 10, so 5 into 10 is 50, minus 7 into 7 is 49, so we get a value as 1. Here 5 into 5 is 25, 25 minus 7 into 4, we get a value as minus 3. So next step we have to reduce this value as 0. For that, next elementary row operation is R3 is minus 11, so we have to multiply this by 11, we get a 121, so we get 11 R3 plus R2. Here we have minus 11 into 11 is minus 121 plus 121, we get a value as 0. So we obtain elementary operation equation as R3 plus 11 R3 plus R2. So we obtain a new matrix as first row is same, second row is also same, third row is changes to here. This is 0 minus 0 is 0. Here 11 minus 11 into 11 is minus 121 plus 121 we get a value of 0. Here we have 1. 1 into 11 is 11. 11 minus 2 plus minus 11 minus 11 is 0. Here we have minus 3. Minus 3 into 11 is minus 33 plus 33 we get a value of 0. So we reduce this to an echelon form matrix. Here observing this, here first row is same, second row is also same. Here 0 minus 0 is 0. Here we have minus 11. So 11 into minus 11 is minus 121 plus 121 is 0. Here we have 1. 11 into 1 is 11 plus into minus minus plus 11 minus 11 we get a value of 0. Here we have minus 3. Minus 3 into 11 is minus 33 plus 33 we get a value of 0. So observing this matrix, we reduce this to an echelon form matrix. Here this is our A. This value is A is to B. Here observing this A, we have 1 0 row. Here we have 2 non-zero row. Therefore, we can conclude that row of A is 2 here. Similarly, row of A is to B is also 2 because here we have 1 0 row and 2 non-zero row. So we reduce this to an echelon form matrix. Call this as equation number 1. Therefore, row of A is to B is 2. Row of A is 2. Since row of A is equal to row of A is to B, that is equal to 2, the system of equation is consistency. Both are equal. So we can write the system of equation is consistent. Say here R is equal to 2. That is our rank for the matrix row of A is to B and A. Also the number of unknowns in the given system of matrix is 3. Since here R value is 2 and N value is 3, since R is less than N, the system of equation will have infinite solution. Already discussed in the note. If R is less than N, the system of equation will have infinite solution. To find the infinite solution, from equation 1 we have considered 3 values as here. From the first row we can consider an equation as 5x plus 3y plus 7z is equal to 4. From the second row we consider equation as 121y minus 11z is equal to 33. Third row all the x, y, z values are 0, so no equation obtained. So with the help of these two equation we have to obtain the value for x, y, z, that is infinite solution for x, y, z. So to obtain, in the note we have, to obtain a solution means we have to find n minus r. Here n is 3, r is 2, that is 3 minus 2 we get a value as 1. Therefore we can consider one arbitrary constant. So consider an arbitrary constant z as k. Here k is some arbitrary constant. We have to choose z is equal to k because n minus r is 1. So we can choose one arbitrary constant, that is our z value. So choose z value is equal to k. This is our step to find an infinite solution. So z is k. Substitute z is equal to k in this equation. We get here 121y is equal to, here take this minus 11z to the right hand side, that is 33 plus 11z, or we can take this as 121y is equal to, here in the place of z we can substitute as k, that is 33 plus 11k. Now for this equation we can divide throughout this equation by 11. We obtain a smaller value as 11y, which is equal to 3 plus k, because we divide this throughout by 11. Therefore we get a y value as, here if we take this 11 to the right hand side, that becomes 3 plus k by 11. This is our y value. This is obtained. If we divide the previous value or equation by 11, we obtain a value as 11y is equal to 3 plus k, that is y is equal to, take this 11 to the right hand side, that becomes 3 plus k by 11. This is our y value. So in the next step, substitute y value as 3 plus k by 11 and z value as k in equation, that is 5x is equal to 4 minus 3y minus 7z. We have an equation 5x plus 3y plus 7z is equal to 4. Take this 3y and 7z to the right hand side, we get 5x is equal to 4 minus 3y minus 7z. So substitute y value as 3 plus k by 11, z is k. So we get 4 minus 3 into y is 3 plus k by 11 minus 7 into k. So we get 4 minus, here multiply 3 inside the bracket, we get 3 into 3 is 9 by 11. Here plus into minus minus 3k by 11 minus 7k. So we obtain a value as, here take LCM as 11, we get, here we take a LCM as 11 means multiply and divide by 11, we get as 4 into 11 is 44. 44 minus, here 11 gets cancelled, remaining is 9, minus 3k, 11 gets cancelled, remaining is 3k. Here minus 7k into multiply and divide by 11, we get a value as 77. So we can take a LCM as 11 here. In the numerator we obtain a value as, here 5x value which is equal to, here 44 minus 9 is 35 minus, here minus 3k minus 77k, we get a value as minus 80k divided by 11. Here in the numerator we can take 5 as common, we get a value as 5x is equal to 5, take a common as 5 means here remaining is 7 minus 16k divided by 11 as it is. Here 5 gets cancelled. We get a value of x as 7 minus 16k divided by 11. This is our x value. So we obtain a infinite solution as x is equal to 7 minus 16k by 11, y is 3 plus k by 11 and z is k. We can substitute k value as any number that is arbitrary. Since k is arbitrary constant, we can take any number. So we obtain an infinite solution for a given system of linear equation. This is how to find the infinite solution for a given system of linear equation. This completes the problem. Here is another problem. Show that following system of equations is consistent and solve x plus y plus z is equal to 4, 2x plus y minus z is equal to 1, x minus 2y plus 2z is equal to 2. Here the procedure is same for all the problems. Here we have to show that the following system of equation is consistent, means we have to show that the system has unique solution. That is, first you have to show that the system, that is row of A is equal to row of A is to B. For that, first you have to consider an augmented matrix as here A is to B is, here A is coefficients in the left hand side of the linear equation, B is 4, 1, 2. So we have to reduce this to an echelon form. That means you have to obtain the second row as 0, first element as 0, second row, third row, first element is 0. For that, you have to use elementary row operation is R2 implies R2 minus 2 R1, R3 is R3 minus R1. So we obtain a new matrix as here first row is same, second row is 2 minus 2 is 0, here 1 minus 2 is minus 1, minus 1 minus 2 is minus 3, here 1 minus 4 into 2 is 8, 1 minus 8 is minus 7, here we have R3 minus R1, that is 1 minus 1 is 0, minus 2 minus 1 is minus 3, 2 minus 1 is 1, 2 minus 4 is minus 2. Here we have to obtain this value as 0. For that, elementary operation is R3 implies R3 minus 3 R2. Here we have minus 3 minus into minus plus 3 into 1 is 3 plus 3, that becomes 0. Here first value is 0, here this also 0. So here we have 1 minus 2 minus plus 3 into 3 is 9, 1 plus 9 is 10 is 2. Here we have minus 2, here minus 2 minus plus 7 into 3 is 21, minus 2 plus 21 we get a value as 19. So we reduce this to an echelon form matrix. Here A is this matrix, here A is to B is this one. Here we have observed this, the rank for the matrix A is 3 because we have 3 non-zero row. The rank for a matrix A is to B is also 3 because here this also an 3 non-zero row. Therefore, we can conclude that row of A is to B is 3 and row of A is 3. Since row of A is equal to row of A is to B, we can conclude that the system of equation is consistent. Also, we have to obtain a solution for a system of equation. Here, since rank is 3, therefore we can take R as 3. Also, we have 3 unknown numbers, that is n value is also equal to 3. Since R is equal to n, which is equal to 3, the system of equation will have unique solution because R is equal to n. So, we have to obtain the system of equation as unique solution. So from equation 1 we obtain, from the first row we obtain an equation as x plus y plus z is equal to 4. From the second row we obtain minus y minus 3z is equal to minus 7. From the third row we obtain 10z is equal to 19. So take this 10 to the right hand side, we obtain a z value as 19 by 10. So substituting z value in this equation we obtain y value, and obtain y value and z value, substitute in this equation we obtain x value. That's the procedure. So consider this equation, that is minus y minus 3z is equal to minus 7. Substitute to z as 19 by 10. We obtain, that is minus y minus 3 into 19 by 10, which is equal to minus 7. Or we can take this as, here taking LCM as 10, we get a value as minus 10y minus 57 by 10, which is equal to minus 7. We take this 10 to the right hand side, we get minus 10y minus 57 is equal to minus 7 into 10 is 70. So take this value to the right hand side, that is minus 10y which is equal to minus 70. Here this is plus 57. So we get a value of minus 70 plus 53 as minus 13, that is minus 10y is minus 13, or we get y value as 13 divided by 10. Here minus minus gets cancelled, 10 goes to the denominator, we get a value of y as 13 by 10. So substituting y value and z value in first equation, it is considered x plus y plus z is equal to 4. So x plus y is 13 by 10 and z is 19 by 10, which is equal to 4. Take this value to the right hand side. Here we obtain in the left hand side LCM as 10. We obtain the remaining as, here multiply and divide by 10 we obtain as 10x. So we we get 10x plus 13 plus 19, which is equal to, here take this 10 to the right hand side, that is 4 into 10 is 40. So also take these values to the right hand side, we get a value as 10x plus, here this value becomes 32, which is equal to 40, or 10x is equal to, here take this value to the right hand side, that is 40 minus 32 is 8, or x value is equal to 8 by 10, that is equal to 4 by 5, that is our x value. Thus the unique solution is given by x is equal to 4 by 5, y is 13 by 10, and z is 19 by 10. So this is a unique solution for a given system of linear equation. These are all some of the important problems on finding the consistency of a solution of linear equation. This completes the problem.